This conference will now be recorded.
Okay, all right. So I think about over the last couple of weeks, we've sort of figured out that we're at the proverbial fork, and I think we're at the point where if we want to, we can either sort of say we've gotten a good sense of the requirements and stop here, or push on to making a full spec based on what we have. So Arthur has an outline of a spec, and I think today's meeting, the main purpose is, which way do we go? I think Gary has said he can sign up for some portions of the spec. The spec is obviously going to be a collaborative affair, and that's basically it. Anybody have any questions? That's at my end.
Yeah, I don't mind working on a spec. I'll have to go back. I'll have to get. I don't have any bandwidth. It's my problem.
Yeah,
I'd
I,
have to
I
go.
appreciate that.
I'd have to go back and. But I can go back and say, listen, we're gonna. The guys are interested in putting something together on paper. Either I work on it or I don't. Sort of way. I don't
And
want to.
Arthur
I don't
has,
want to. Yeah.
go ahead, please. Sorry.
I don't want to sign myself up and then get cornered as I don't
Yeah.
have the bandwidth, and then just everybody's not happy. So I'll go back and make a pitch and see what the response is. Yeah. I think they don't mind. Like they don't mind attending these kind of consortium or meetings is fine. But when you actually have to put the head down and do some work, then I need to get agreement or signed off on it. Yeah, it's the problem, isn't it? In general.
Yeah, it is.
I mean, I think what you're saying, Bap, is if everybody does a tiny bit, then and we're working towards a common goal, then eventually we will produce something. But it needs it needs people to turn up and participate and contribute.
Yeah.
So yeah, and I mean, I think Damien, you actually have contributed quite a bit already. So
I've talked a lot. I haven't.
Yeah. Yeah.
Putting something on paper is a different story. Then you have to.
Yeah.
Yeah.
So I mean,
Yeah.
I mean, you asked me. I mean, I'm a bit like Damien. You kind of, it's one thing to turn up and talk. It's another thing to actually do something. But you asked me to put pen to paper. I did that, and actually it was quite easy to do what I did. And so I wrote an overview, which I think is my understanding of where the consensus is. And then I actually, should I share? How do you share? How do you share? Is it screen? Is that? Oh, here we go. What's going on? Let's try this.
It says here to share. Ask the organizer to make you a presenter.
I did. I thought I made him an organizer already. Let me see if I can make you a present. Oh, there you go.
Okay, yeah. Can you see anything?
Yeah.
Yep.
Yeah. So I wrote this overview, which has said caps my current understanding of the consensus. And then basically we need to define the interfaces to the layers above and below. You need to define the services, define the encapsulation. If they're different operating modes, for example, if we define more than one method of error correction, then I guess we need to find different operating modes for that, and they need a definition of configuration and control registers. So I I mean, I could read through the overview to see. Should I do that? I mean, it shouldn't take long.
Yeah, I think so. That
Okay.
would be good.
Yeah. Okay. Yeah. So I'll read through this and see if there's any disagreement. So I'll just read it. So this is the Open Systems Interconnect model abstracts flow of data from a communication system into a number of layers. Data flows through the layers, and each layer provides a particular service. So basically what I'm doing is I'm introducing what a link layer is and what it needs to do. Individual layers interact with their peer layers at the other end of the communications link and will send data to and from the layers above and below them. So it's basically saying the OSI model is a layered model. The data flows from the layer above to the layer below, and each individual layer communicates with its peer layer at the other end of the link. The lowest layer in the protocol stack is the physical layer, which is responsible for transmitting a raw bit stream over the physical medium. File layers communicate directly with each other through the particular physical medium, which in the case of die-to-die might be a silicon interposer or package substrate. And with the data link, also link layer above. So basically the link layer goes above the file layer. Physical layers are defined to support a particular medium, provide a given data rate, defined bit error ratio. The purpose of the link layer, so basically thing with PHYs is because well, particularly in terms of die-to-die environment, we really care about latency and particularly power. So depending on the nature of the die-to-die interconnect, you might have a different physical layer because that will give you better power optimizations for the particular medium you're using. So basically, you can mix and match physical layers in your protocol stack. The purpose of the link layer is to provide reliable transmission of the data frames between two nodes connected by a physical layer. Standard interface is defined between the link and the file layers to enable a common link layer to interface to different PHYs. So basically, the link layer is providing an error recovery. Well, I mean, it's basically its job to do some error recovery service, and you mix and match different PHYs with a standard link layer through a standard interface. And as I said, these PHYs will be tailored to particular requirements, the desired die-to-die physical connection, but all provide a similar data throughput and a specified bit error ratio. Main requirements for die-to-die PHY are high density and low power dissipation per bit transmitted. D2D PHYs currently being defined by ODSA provide similar service in terms of throughput and bit error ratio, but do not necessarily have a common service interface defined. It will be necessary to define a shim layer for each of the PHYs to translate between the service interface and the common standard interface. The shim layer, or perhaps logical file layer, may need to include service for distribution on transmit and aggregation and DSKU on receive, and link training specific to the PHY. As data flows down the protocol stack, each layer introduces encapsulation of the data stream. This encapsulation is interpreted and stripped by the peer layer at the receiving end of the link. This document defines a link layer suitable D2D applications. Link layer supports throughput of 1 terabits per second with single cycle latency and provides an error correction service. Low latency and high throughput are the main requirements for a D2D link, and for this reason the link works with fixed length 512-bit flits handed off from the layer above. The link layer provides necessary encapsulation for the error correction service. Okay.
That's pretty good.
That's basically the overview. That is, yeah. Go ahead. Yeah.
Yeah. One quick question. So so just to make sure I understand what the bounding box is, there's kind of an upper layer, and then all the stuff in terms of distribution and yeah. So basically, it's encapsulating with error correction, and that's where we're defining the link layer, correct?
Yeah.
I'm just what I'm trying to.
Yes. Yes. So go on.
Oh yeah. So because what I was trying to motivate is the single cycle latency. so I just what I want to understand is how much this is bounding the problem to fit within a single cycle, and just also thinking about what single cycle means, because I think of single cycle latency and I think of 300 picoseconds, but but other people have a much more relaxed view of single cycle. So
Yeah.
that's why I was wondering kind of what and maybe that's not, maybe this is sufficient, the overview is sufficient to cover this, but just kind of a typical single cycle latency and what technology and what the assumptions are maybe should be discussed later.
Yeah, maybe we should say low cycle or something, because you're never going to do the FEC in a single cycle. The FEC is
Okay.
in the link layer, so you'll
That's
do the
fine.
link layer. You'll do the retry without the FEC in a single cycle. You plug in the FEC, which we are defining to be in the link layer itself. I think is the idea, isn't it? Within the black box. So yeah, then depending on what flavor effect, then you may be 2 cycle, 3 cycle. You might have different cycle latencies each direction. So.
Okay, fair enough. I mean, I was thinking that it wouldn't always require FEC. The FEC would.
You can rephrase it
I
to say
mean,
it adds with the.
yeah.
You can rephrase it as with just a error recovery service in the form of CRC or whatever. Then the expectation is you would basically go through the link layer in a single cycle at a
I
particular
mean,
frequency, then add a FEC. Yeah.
sure, I can delete single cycle from this if that's an issue. Yeah, and I mean it's not, it's probably not even relevant. I mean, so that is an implementation detail, and it's probably not even necessary for a standard. I mean, what is so basically, if you do it in more than one cycle, you're going to get more latency, and that'll be depending on the implementation. So the vision I was trying to actually, I'll get onto the interfaces, because there's a lot of angst about the interfaces and whether we should call them LPIF or whatever. But I think the interfaces can be so simple we don't even need to call it anything. So I think I was just thinking, what happens if you just define the service interface, basically the interface, the layer above, as 512 bits with already valid signals, and clocks,
Well,
and then
yeah, I
yeah.
was going to say the 512 probably not a good idea either. That's a lot of level of detail, but and it's actually would be 576, I believe, with the FEC and aux. But can you define it without defining the number? I mean, you are kind of limiting. It's a very restricted implementation now. To get 1 terabits, you need to run your link layer at 2 gigahertz. So it just seems like maybe that's a little bit more detailed than needed for a high-level standard.
Okay. So when I so basically, so just to be absolutely clear, the 512 bits was to the host layer, and and that's before encapsulation. So when you hand off to the PHY layer, it will be more than that. So the idea is so basically what the data flow looks like. So you hand off a wide load of data, and all right, you're saying 512 is too few. And then you encapsulate it and then you hand off a wider chunk to the shim layer below.
Well, sorry to jump in here. I think the important thing to define here is really the framing, not necessarily the interfaces. I mean, this is a different way to look at it. I mean, we can decide one way or another, but I view this kind of as defining what the framing is. So the interfaces just provide a stream of data, and then the link layer takes that and packs it up into some, some 512 plus, extra that then gets streamed out to the other side. And so rather than depending on how much of an interface we want to define, at least logically speaking, that's what in my view that the link layer is doing.
Well, that makes it even simpler. Yeah.
Yeah, I know.
Yeah. Yeah. I mean, that's fine. I mean, it's just we did spend a lot of time talking about whether or not to use LPIF, but if we just say, yeah, it's just an arbitrary stream of data, and this is how you encapsulate it. Yeah, I mean, that's why not. Yeah, I mean, it's.
I'm definitely not trying to oversimplify it, but if I think about how you where are you trying to encourage interoperability? And the question is, are you trying to encourage interoperability at the layer interface, or from chip to chip interface, and would the details of the actual physical interface be kind of swept away? And so that's why I think at the heart of this, I think you're defining a framing, and then if you want to go to another detail about how to implement this to interoperate with a PHY of a particular kind or something like that, and then try to come up with a standard interface, then we can go that step. But I think it's probably more important, at least in my view, it's more important to define the framing aspect of this.
Okay.
If you're not, sorry, yeah, go ahead, Damien, you first.
Yeah, just to ensure I'm on the right page, just define the encapsulation basically, what the container width is a 512, is a 1024, and then define how that's encapsulated for error recovery, and not talk too much about the physical interfaces, whether it's 1 gig 1024, 2 gig 512, or whatever you want to do. That's kind of more implementation specific. Is that a general idea?
That's what I'm suggesting, but that's kind of just my take on this and my philosophy on where we should go with this. But.
Yeah,
no. I was going to say though, if you come from my perspective and probably other people's perspectives, if you're providing IP cores, it is useful to have an understanding. Let's say, I mean, it needn't be set in stone, but I mean, if there's some sort of agreed data widths out there and associated signals, then that is useful. Let's put it that way. So I mean that I think where it's useful to define interfaces is where you're bolting together cores, functional cores that come from different sort of providers. So
sure, yeah, no, I buy that, sure.
Yeah, you could standardize on the definition of the header and data, let's say, and just parameterize. The data width could be 512 or 1024.
And if that is what I mean, if it is going to be, say, a choice of 512 or 1024 or a multiple of 512, then it might be helpful to just state that, somewhere, Yeah. Okay, that's fine. And then, so I mean, this is just a skeleton, that piece just we start with and then fill out. So then, so basically the definition of services.
It's very,
and then
it's very good, by the way. I appreciate you doing it. Thank you.
Oh, that's fine. No, yeah. Yeah, I wasn't. Sorry, I didn't mean to be defensive either. It's just, it's fine. Please click holes in it.
Oh yeah. Don't take it. I would, like I said, I'm not criticizing. I'm just offering up a different philosophy or view of this. But no, this is good.
Yeah, no, it's really, really good to hear the. Yeah. No, I'm very grateful to hear they get. Yeah. No, I mean, I don't. And the other thing is, I don't really want to own this, as a starting point. So it's great if the more people contribute, the better. Right. So then I said so the basis of the services are error correction, and basically there are two ways of doing that: is through retry or through FEC. So CXL gives a model of retry. I would have thought that any physical layer with, I don't know, it's my opinion, but once you sort of start getting a bit of ratio service better than 10 to the minus 15, you could probably get away with retry. Less than that, you probably need a FEC. But I think we're agreed you need to offer both depending on the capability of the PHY. So
Yeah, and you need to offer different types of FEC depending on the PHY as well, on the nature of the bit, are sort of bursty or random. So that's the sort of thing. And then I've been chit-chatting with another, and they're looking at revving the CXL, basically moving to the next generation of CXL, which is 3.0, and it's a totally new interface and new packing rules and all sorts of stuff, nothing like the previous one.
I mean,
So,
I wasn't suggesting it has to be compatible with CXL. I was just saying it's a reference.
I'm just saying that if you do look at it as a reference and you say, okay, if you look at the 2.0 as a reference and you look at what the various ideas there in packing, by the time we've the actual CXL consortium is moving on such that they're having a whole new definition now, basically, for a year from now, of what this interface should look like. So they're changing the for example, I was talking about the retry capability previously, and it was kind of the mechanism was tied into the fact that there was this concept of all data flits, for example, right? In the new rev, that's gone, and every single flit has to have a header and data. There's not just things in all data flit anymore. So that retry mechanism now all changes. So all of a sudden I got a new link layer. Basically, it's not compatible. The one I have won't be compatible with the next generation of the spec.
Is the Rev 3 one simpler? The retry mechanism simpler because they've done away with the all data flits?
It's simpler, yeah, a little bit, but it's all in development. You see, it's all. I mean, it's like Rev 0.5. Like you won't see. It's all been discussed at the minute. Partners get access first and the usual stuff, and then the spec might be released. But so it's in flux. Like, so I don't know what we do for. Like, are we trying to develop a link layer spec and we're referencing something that's moving, or like how do we come up with our own?
No, I suggest we come up with our
So this is the problem
I mean,
because
I think if you start with 2.0, it's obvious what the simplifications are. If you do away with the old, I mean if you do away with the old data flits.
Yeah, they're talking about going to a different flit format, effectively, different method of packing. So widening the flit from to 102.4 up to 2 or potentially 204 bit.
Yeah.
So this kind of thing, it's just.
I mean, I guess what we're really saying here is that whoever signs up to define the error correction through retry task has got a bit of grunt work to do, and somebody might possibly have already implemented something, and they could propose. Somebody might already have some state diagrams around this that they could contribute that are not CXL, but but maybe inspired by CXL. I mean, it's it'll. I mean, I might even be able to do that. I mean, I can't commit. It's I guess it's yeah. I mean, this is the old problem. I mean, there are people who call into this who may be in a position to come up with detailed technical proposals based on stuff they've already kind of implemented and tried out. Don't know if that's the case, but it's possible. Yeah.
Hey, Arthur, before we lose Damien, I wanted to, so I think the purpose of this meeting, or maybe we can decide it over the next two meetings, is, Arthur's offered up this outline. I think who we have is who we have. Do we want to glue a spec together or slow things down? I think that was the intent of this meeting, and maybe Damien, you can sort of say something.
Yeah, or do we need more participation? We're a small group by the looks of it, so like, do we need the big dogs to contribute? Because the big dogs are working away in parallel. You know what I mean?
It is, but I found that getting a document going on the Bo group with a small number of people, and we just sort of, it takes forever, but we build up decent momentum. And the one thing is, if you can get started, then you sort of get more people piling on if they see that there's a document evolving. That part I can answer. I've seen it happen twice now. So just getting started brings more people along for the ride later.
Yeah,
but
I mean, I don't mind getting started, but I mean, we can have a high level. Once you have something on paper at a high level, you maybe don't have to have every single detail worked out, but just try and have something right. Yeah, you say draw a bit more interest from the SOC guys mainly.
Yeah, I mean, I think if we, I mean, I think you nailed it last week, Bappy, when you said it was kind of people losing interest. That's probably because we've been talking for a year, not really produced all that much. But if we start writing a document, I think that it could rekindle some interest, let's say, from a wider group. So I think it wasn't. I mean, it didn't actually take me that long to write this up. So I mean, if you've got a Google Doc and anyone can edit it. So if people just want to add to it, it may it may go somewhere. And I mean, and I think the feedback. I mean, the two pieces of feedback I got today is, get rid of the thing on single cycle and don't be too prescriptive on the interface. That's very useful. I mean, I don't feel like I own this document. If people want to add to it, that's fine, or even correct it. That's good.
I have one question. So I'm a FI designer and in the Bo meetings sometimes. I know, Bobby, in the Bo meetings, there was a question a few weeks ago about like training patterns, right? And they said, oh, that the link layer can do that. So something here should address that, I would think.
Yeah, so what I did is I referred to a shim layer. So
sorry, Arthur, I have to go, guys. I'll tune in for the recording next week, or the next part of it. Okay.
That's great.
All right. Sorry. Bye.
Yeah, I mean, the various FIs are going to each have slightly different service in interfaces. So in the overview, I talked about a shim layer, which would do the adaptation between the specific FI interface and this generic layer, and that would could call out a logical FI layer, and that would contain the training patterns that. So did you say Bo? So you said. So the question on Bo.
Yeah, I mean, the concrete example.
I mean, it probably doesn't need much training. Is that for lane realignment. What's the training for on bows? Is it just test patterns and stuff, or what?
Well, clock sample alignment. So yeah, they still have to do some amount of, duty cycle correction, or there's some calibration.
So basically, each file would have its own sort of shim layer, and the training would be just something, I guess, that'd be done at the start of day, and these parallel interfaces probably have quite simple training requirements. So yeah, that's where I'd envision it going.
So it's like another layer. I guess there was a specific discussion of having a 64-bit user-defined pattern and making that a requirement, I guess, but it wasn't in the phi layer. So it's got to be in some layer. Yeah.
Yeah, here we are. So I put it here. The D2D phi is currently being defined by ODSA, provides similar service in terms of throughput and bit error ratio, but do not have a common service interface defined. It will be necessary to define a shim layer for each of the phis to translate between their service interface and the common standard interface. This shim layer, or perhaps logic flow, may need to include service distribution, transmit, aggregation, dispute, receive, and link training. So it is mentioned in the overview. So that's okay.
Gotcha.
But I was assuming that'd be a start of day thing, and once it's up, everything would just run.
Yeah, I think it might be a little bit. Sorry, it might be helpful to. I know we have lots of diagrams lying around somewhere, but it might be helpful to just throw a diagram in there that says, here's an example of, well, I don't think you need to have an example of each case, but yeah, just to highlight that there's some number of phis and some adaptation layer or shim layer between the link layer and that. I think it's also good to sort of identify what in the link layer is going to change based on the phi, and maybe it's not related to the phi and more towards the raw bit error rate and the system characteristics desired. So it might be good to talk about that at some point, just what the trade-offs there are.
Yeah.
Oh, sorry. Then one last thing, and I'll let. Sorry, just one last thing, which is then also for any link layer implementation, how many of the different flavors of error correction detection does it have to support? So does for full compatibility, does an implementation of the link layer have to support all those because it could be paired up with something on the other side that supports anything, or is there to what degree do we want things to interoperate? I think is a good good framing question.
I think so basically the error correction mechanism. So the issue is the phis that there isn't a common bit error ratio service provided by the phis. I mean, some of them. So if you're using a PAM4 SerDes, you're going the underlying bit error ratio service is going to be pretty bad. But if you're using something like bunch of wires or OpenHPI, it's going to be very, very good. So I think you'll know in advance which phi so the problem we have is we need to find a sort of link layer that works across the ODSA phis. So
sure.
And if there's a requirement, if there's not a fixed bit error ratio, we need to offer different modes or different modes. But I'd have thought the link layer would be always tied to a particular PHY type, and for that reason, if the PHY you're using did not need strong FEC, then there'll be no need to have strong FEC in operating in your link layer. So I think the interoperability issues are a lot easier in a die-to-die environment because basically it's a completely fixed configuration, and you know in advance what PHY you've got, and you know in advance what channel you've got. So I don't think. I mean, sure you could specify, whether what's optional, what's not. But I think in terms of configuration, I think you're going to know right from the beginning what you require, what you require in terms whether or not you require the FEC, for example. But
yeah, that's sort of my expectation as well, and so I think this is, again, I go and I probably sound like a broken record at this point, but when I think about one of the things that we need to consider is, from the interoperability perspective, is what different parameters have to be the same across the entire stack for two chiplets to talk to each other. And so this is just one facet of it, which is the error correction in the link layer. So both sides of the link have to agree. And so that may be a perfectly reasonable thing to do, is require that and say at design time it's configured to be CRC plus retry, and so the other side has to be CRC plus retry, and everyone's happy. And then everything else has to agree. Of course, you can't hook up a SerDes to a bow, for example, and that kind of stuff. So there's this trade-off between generality and specificity, and I think we need to be cognizant of that and make sure we understand where we're introducing parameters that have to be the same, or if we want to make designs more interoperable or chiplets more interoperable, we may have to adopt different mechanisms to make that happen. And so I don't really have a strong opinion here. I'm just pointing out that I think there's a trade-off.
yeah, fair point. Yeah. So it's basically the fewer options, the better, is what you're saying.
Well, I'm kind of saying the less constrained you make all the decisions at design time, the more interoperable things can be. But the flip side of that is that it's just if there's a lot of choices there, then interoperability has a cost. That's why I'm just, some of the choices we make here, I just want to make sure that we evaluate those in the context of interoperability, and whether we think those, whether that's in service of that goal, or we don't care about that goal, or it's just sort of high level thinking on that.
Okay, so we've got about 15 minutes. There are three things. One is follow on Damien's conversation, or do we want to fill in this framework? Two is where to fill it in. Yeah, I personally like Google Docs, but the big problem in my mind with Google Docs is it doesn't come with any terms and conditions. As you put it up on a Git repo, you inherit the Git repo's terms and conditions. And three is the mechanism. We can just, my preferred option is to follow the bow mechanism, just to throw the document out there into the public with no copyrights, and then we sort of convert it into a into a spec as we near completion. But those are the three things where, who, and then of course the fourth one is, who do, if we're going to go ahead, who does what, starting and writing small sections. Anyway, so it would be nice to have a discussion about that in the next 15 minutes.
I don't have a strong preference about Google Docs or GitHub. Although I've seen the both spec and on the GitHub thing, and the live version was in some strange format that you had to get a web plugin and all sorts of things like that. So I think I would prefer not to have that, but if it goes to GitHub and there's a precedent for doing that, then I guess so. But I thought it was kind of clumsy.
It is. I mean, you don't have to. We don't have to use. So basically, there are two things. We can sort of edit a native to GitHub in GitHub Markdown format. So we jump through a million hoops on the bowl. I was following the logic that the P4 guys had, and basically this allows you to print out a spec as HTML, PDF, or but sort of version control the document. There's this weird editor called Madoko. And so now I have three versions. The Madoko is the sort of the source, and every so often I do a PDF dump and an HTML dump.
Yeah. I mean, I'm so a point of comparison. I do a lot of documentation work for RISC-V, and so there we've transitioned everything from LaTeX to ASCII doc, but it's still kind of kludgy because you have to install all these packages and do all this other thing. So anything that I think anything that has a low barrier to editing is good. I also think that having version control is good as well, and somewhat to some extent, Google Docs is actually pretty lightweight in both of those regards because you can do version control. It keeps track of all your edits, etc. But it's not a true version control like GitHub. So yeah, I don't know. I mean,
well, no. So the source doc just gets managed in GitHub, and you just check it in, and that's basically your version control, and you build whatever whether it's ASCII docs or Madoko is really painful. Anything, but basically the idea is to maintain some text.
Yeah, I know. No, I understand. It's all painful. I haven't, once you get it set up, it's fine. But getting to that point is the barrier to entry is pretty high in a lot of that stuff. And so, in some sense, that's good because it keeps kind of the drive-by critics away. But it does raise the barrier to entry, and people have to be really motivated to jump through all the hoops to edit. So I don't know. GitHub's nice because there's a lot of feedback and feedback mechanisms and review mechanisms there. So I wouldn't be opposed to moving it over there, but the Madoko stuff I didn't really care for. So, but I wish I had more than just negative criticism about it. I can't think of anything better at this point.
Yeah, it's like that quote about democracy.
Yeah, I know exactly. I just used that the other day about ASCII doc, to be honest.
So what's the issue with Google Docs again, Bappy? What's the problem with that?
The catch is that unless we take a PDF, and the catch is that it doesn't have any terms and conditions associated with it, right? When you put it on GitHub, you inherit nobody can sort of use it and say, look, you guys didn't you guys promised some rights, or I followed your instructions and everything broke. We're sort of saying, here it is. It's we accept no responsibility. It's take it at your own risk. Google Docs doesn't come with an implied license of that sort.
I think we can no header or something like that we can put there to say, hey, this is developmental, as is.
We could, but honestly, I would just prefer to slide into an existing structure rather than invent a new one.
How's the BOW spec licensed?
It isn't right now. I mean, it's basically a copy. It's basically it's some version of the Apache 2.0 license, I believe, that the OCP runs on its primary Git.
I see.
So we're a repo in that on the primary Git, and we inherit everything they have.
Can you point to that in this document, and then would that be sufficient to inherit or do you have to have a full boilerplate?
Well, we could do it this way. Maybe we do. So we didn't do that from day zero. What we did was, it's a small group of people, and we just wrote a Google Doc until it got to some stage, and then sort of transitioned it over to as we had more people come in, then we transitioned over to the Git repo.
Mhm.
So there was a small group of people worked on it in a Google Doc format, where it was everything was uncertain, but we didn't release it and just sort of said, here's an open spec. It was more like you'd release a version of it in some conference and say, here you go, here's where it is right now.
Mhm.
That's the sort of a halfway house. Or look, I think the other option is to just do it as in GitHub Markdown. Just do it, GitHub is a reasonably nice editor, put some pictures in, forget, and it's reasonably easy to edit, and we don't have any complicated formulas or text. So put it on GitHub, but just write it as a native Markdown doc. It'll look pretty on the web, but it won't print out nicely as a PDF document.
Yeah, I was going to ask, is there a PDF converter there? I don't recall.
I hunted and I couldn't find one, but I mean, I don't see that. I mean, we can always change later, but for now, given where we are, maybe that's the easiest thing. Just write text directly in Markdown.
I mean, personally, I think in the near term, it's probably easier just to stay in the Google Docs format. If there's some way we can inherit a license or, add enough disclaimers that people don't get, bent out of shape. And then make that migration later and hope that the documentation universe is nicer by then. But I'm not going to hold my breath. But yeah, I don't know. I'm just throwing out ideas. I don't really have a strong preference. None of the.
So
I think Google Docs
I've
is fine.
written in Markdown. It's not too bad. Markdown isn't that bad.
Yeah, I know. None of those languages are terrible. Just they're yeah.
And you can edit on Git on the web
Yeah, for sure.
Take a look at it. If it's not Google Docs, you don't do simultaneous edits, etc. But that's the point of version control. But if you guys like it, if you guys can live with it, that would be my suggestion.
Yeah, that's
So
fine.
which one, Bappy?
Just use GitHub Markdown language, right? Just edit a page directly in GitHub Markdown language.
Yeah,
So,
if that's what you want to do, it'll be something new for me, but if that's the right thing to do, I'm okay with it.
Give me one second.
It's a little bit. It takes a little bit getting used to going from sort of a WYSIWYG environment to Markdown or any of these text-based formatting things. But Markdown's pretty lightweight. The GitHub one is pretty lightweight. And, I mean, if I were stuck on a deserted island with Markdown as my only way to write text, it'd probably be okay. But
so here you basically, you just go edit, and it kind of looks like this. This is Markdown language.
The way to do simultaneous edits is that you fork and do merges and stuff like that. So
yeah, but it's not going to be real time. Like you're not going to see what the other person types in real time the way you do in Google Docs.
Correct. Yep.
So here you go, cancel changes, and this is what it looks like. So right, so section headers have a hashtag, 2 hashtags, subsections, blah blah blah.
Yeah, and there's a preview thing too. The next to the edit
Yep.
tab. Yeah,
There you
see
go. So I haven't found a good Markdown to PDF converter, but I mean, people can just print the web page, and it's not the end of the world.
Pappy, I have to drop off quite soon.
Okay, so then maybe we need a longer discussion. It's 10 a.m. So then our next step would be to figure out, which sections we want to fill in and who does what, and at what rate. Do we do it over the next quarter or the next 6 months, whatever?
Yeah, I mean, I think there's enough interest to persevere with this. I mean, you might as well keep going for a few more weeks, see what happens, and as you say, it may take off. And it seems like both Gary and Damien are wanting to contribute.
So why don't I do this then? I will create a new repo called the ODSA link layer and enter your text into the into the figure out how to enter your text into it, and then let's see if we can play around with that.
Is it possible to get diagrams into this markup language? See.
No, you'd have to edit the diagram and insert it as a JPEG, I think.
Okay,
Or,
so just create a JPEG and insert
yeah.
it. Okay.
Okay, maybe I'll insert one of the diagrams from our paper in there.
Yeah. Okay.
All right. Thanks all. Thanks, Arthur. Huge thanks for saying it. Was a really good discussion. Thank you.
Yeah, you're
thanks
welcome.
for saying
And yeah, and thanks for feedback, everyone. Yeah. Okay.
All right, all. Have a good day then.
Bye.